Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to subscribe and share my videos to your friends and to your friends' friends. That's the only way you can help me promote my channel and to keep me going, refreshed, and inspired. And I'm very willing to share my knowledge, especially topics in civil engineering for your benefit. A rectangular beam, 200 by 260 millimeters in cross-section, carries a uniformly distributed load of W kilonewtons per meter. Using 80% stress grade apitong for meters long and the allowable stresses for bending and tension parallel to the grain of 16.5 megapascals, compression parallel to the grain of 9.56 megapascals, and compression perpendicular to the grain of 2.2 megapascals, and modulus of elasticity of 7.35 gigapascals, then shear of 1.73 megapascals. Determine the safe uniform load without exceeding the allowable bending stress, the allowable shearing stress, and the allowable deflection of L over 240. So the simple support of the beam is 4 meters long. First, let's determine the allowable load, uniform load if bending stress controls. So bending stress is 6m over b8 square for rectangular section. The allowable bending stress for both tension and bending is 16.5 megapascals. So 16.5 equals 6 times m, 1000 square, assuming moment is in kilonewton meter. So we multiply 1000 square to convert it to Newton mm to match with this unit in megapascals. Then B is 200 mm, H is 260 mm quantity square. So solving for m in kilonewton meter, 37.18 kilonewton meter. Then we equate it to maximum moment for a simply supported beam loaded with uniform load of WL square over 8. So 37.18 is W times 4 square over 8. Therefore, the uniform load, if bending controls, is equal to, it should be less than equal to 18.59 kilonewtons per meter. So that's it for the first part. For the second part, allowable shearing stress. So shear stress max is 3V over 2 area. So allowable shear stress is 1.73 equals 3 times maximum shear. Assuming shear is in kilonewtons, so times 1000 to convert it to newtons over 2 times area of the cross-section 200 by 260. So shear is equal to 59.97 kilonewtons. Then the maximum shear is occurring just to the right or just to the left of the support, and it is WL over 2. So 59.97 equals W times length 4 over 2. So W therefore can now be computed. It is equal to less than 29.99 kilonewtons per meter. And finally, without exceeding the allowable deflection of L over 240. So L over 240 or deflection is 5WL to the fourth over 384 EI. So this is the maximum allowable deflection for simply supported beam loaded with uniform load 5WL to the fourth over 384 EI. And we equate it to the limitation of the deflection of L over 240. So L over 240 equals 5WL to the fourth over 384 EI. So let's cross multiply. Let's cancel L. So 384 times E 7310 megapascals, I 260 cube over 12 over 240 equals 5W times L cube times 1000 to the fourth. Because this is in kilonewton per meter, length is in meter, so kilonewton per meter times meter cube is kilonewton meter square. Then in the left side, everything, the units here are in newtons and mm. Here it should be in newtons and mm also. So kilonewton per meter times meter cube is kilonewton meter square. So to convert this to newton mm square, we multiply 1000 cube. So from there we can solve for W, which is in kilonewton per meter. So W is 10.71 kilonewton per meter. If there is a last question on the safe uniform load that the beam can carry, then the answer, the safest load, is the lowest among these values, so it is 10.71. But there's no question, so these are the answers to each part.